Hey guys, welcome back to 5.2 or Chapter 5 Trig. I remember today we'll have our optional Zoom meeting for homework questions. So that could be either yesterday or today's homework. So make sure you're working through it in a timely manner, please. Um, Today it's honestly just a lot of yesterday / last chapter stuff. So I don't think it'll be terrible. So we're going to use trig ratios and identities to evaluate trig functions. So we're just going to jump right back into an example. So if t equals pi over 6, find the value of the 6 trig functions. So remember from yesterday, we had our unit circle. Well, I'll try. That's symmetric circle. So we're going to go over pi over 6, and that'll be our terminal point, and we'll have to find our triangle to find our trig ratios. Well, let's convert this to, what am I even trying to say? Degrees. So pi over 6 times by 180 over pi. Pi's cancel, 6 goes in 180 30 times, so it's a 30-degree angle. Okay, and so we're going to go over 30 degrees, and that'll be our point there. This is a 30-degree angle. So if we make our triangle, this is 90, this is 60, and so that would make this square root of 3, this would be a positive 1, and this would be 2. Now remember, if we were on the unit circle, our triangle would be 1, and we have to divide by 2, so it would be 1 over 2 and square root of 3 over 2. Well, I do want to show you something though, so keep these two triangles in mind. And so we want to find the value of our 6 trig functions. So let's just start with sine, which equals y over r, right? Or opposite over hypotenuse. So if we do this left one here, we got 1 as our y and 2 as our r. Well, let's do this one right here on a unit circle. Your opposite is, oh, what happened here? Equals 1/2 divided by 1, which equals 1/2, right? And so the trick is that no matter how big these side lengths are, these triangles are similar, right? All the same angles. And so their ratios have to be the same. And so if you're trying to find the values for the trig functions, you don't necessarily have to do this work to put it on the unit circle. Sometimes it's tricky knowing when you have to and when you don't. Just for these types of problems, when you're finding your sine, cosine, tangent, yada yada, you don't need to, because the ratios will be the same. So we got sine is 1/2. Cosine would be adjacent over hypotenuse, so square root of 3 over 2. You could easily verify that would work here. Square root of 3 over 2 divided by 1, square root of 3 over 2. Tangent would be opposite over adjacent, so 1 over square root of 3. We rationalize, so square root of 3 over 3. So there's our main 3. Well, now let's do the reciprocals. Okay, so cosecant would be 2 over 1, which is just 2. Secant would be 2 over square root of 3, which if we rationalize, you get 2 square root of 3 over 3. And tangent, we originally got this, so if you just do the reciprocal of that, you get square root of 3 over 1, which is square root of 3. And so that would be our answer. Those are our 6 trig functions. Those are the values if t equals pi over 6. Okay. Same thing. 5 pi over 6 now. So let's convert 5 pi over 6 times 180 over pi. Pi's cancel, 6 goes in 180 30 times, so you got 5 times 30, which is 150 degrees, so that's our angle right there. So if I draw this off to the side, go over 90, then we got 60 more. So we got to use our reference angle to make this triangle. So let's see, I said we go over 60, so this is again a 30-degree angle. That would be 60, this 90. So this would be square root of 3, except we're going negative on the x value, so it's going to be negative square root of 3. This is going to be a positive 1, this will be 2. Again, we could convert this to unit circle, but the ratios will be the same, so I'm not going to do the work with fractions. So sine would equal 1 over 2, so 1/2. Cosine would be negative square root of 3 over 2. Tangent would be 1 over negative square root of 3, so you rationalize, you get negative square root of 3 over 3. Man, this problem's almost identical to the last one. Cosecant would be 2. Secant, you get negative 2 over square root of 3, which you rationalize, so you get negative 2 square root of 3 all over 3. And then tangent, reciprocal, so negative equals negative square root of 3 over 1. So that right here would be our answers. Okay. And so now let's find the exact value, 5 pi over 3. So this is really just what we did last chapter. Now again, if they ask for exact, that means don't type in your calculator. I don't want decimals, right? Exact means they want the exact answer. So this is a lot easier than the last problem. You're just finding one. 5 pi over 3, let's convert. 5 pi over 3 times 180 over pi. Pi's cancel. 3 goes in 180 60 times. 5 times 60 is 300. So that's a 300-degree angle. So we're going to go over 90, 180, 270, and 30 more, which would make this a 60-degree angle. This would be a 30. This would be a 90. So this would be negative square root of 3, because we're going down. This would be a positive 1, and this would be 2. And so we just need to find sine. So sine would be opposite negative square root of 3 over 2. Just like that. Okay. What is going on? Alright. Let's do another one. 19 pi over 6. You got 19 pi divided by 6. Oh, that's a nice 6. Got to convert. Sorry about that. 180 over pi. Pi's cancel. 6 goes in 180 30 times. So you have 19 times 30, which I don't know off the top of my head. That equals 570 degrees. And so we need to find an angle coterminal with that. So let's subtract 360, if that's okay with you guys. And that gets you 210, which looks a lot better for us. So 210. So we go over 90, 180, not quite 270, so we go 30 more here. So again, it's important that we know our reference angle. We went 30 over 180, and that's going to be our reference angle because that's the closest way back to the x-axis. Draw our triangle right here. So this would be a 60, 90. So this would be negative square root of 3. This would be negative 1 because you're going down, so we always have to remember our negatives. And then this would be 2. And then cosine, we just need to find cosine, which is adjacent, negative square root of 3 over 2. Okay. Which makes sense. All students take, the only values positive in here would be tangent or cotangent. So it makes sense that this guy is negative. So you could use trig identities to solve this one. I don't think I'm going to go over that. I think there's a lot easier way. So first off, we got to recall secant is reciprocal of cosine. And so that would equal, sorry, brain fart, r over x. So we can always write a whole number as a fraction over 1. So secant equals, well, 2 over 1. So r equals 2, x equals 1, and we know it's in quadrant 4. So let's draw this. Quadrant 4, radius is 2, our x value is 1. Well, if you see here, based on our special triangles that we've been memorizing, that would make this have to be, this one have to be a 30 degree, this would have to be 60, and that's a 90, because 30 opposite of 30 is to 1, opposite of 60 would have to be the square root of 3, except our height's going down, so that needs to be a negative value there. Okay, and well, look, now we have all of our values, so we can easily fill this out. So sine equals opposite, negative square root of 3 over 2. Cosine should be the reciprocal of 2, right? Which adjacent over hypotenuse would be 1/2, so it worked out good. Tangent would be negative square root of 3 over 1. And then we got to do cosecant, which is reciprocal of this. You get negative 2 over square root of 3. Rationalize equals negative 2 square root of 3 over 3. Secant there, I told us, equals 2, which that's reciprocal of 1/2. And cotangent would be negative 1 over square root of 3, which rationalize, you get negative square root of 3 over 3. Okay, and so these are all of our values. It's also important to note which ones need to be positive and which ones need to be negative. We're in quadrant 4. All students take calculus, which means cosine and its reciprocal, which would be secant, should be positive, everything else negative. So, yep, that's negative, 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 and then secant and cosine are positive, so it checks out. Okay, so given our terminal point now, they give us our terminal point, find sine, cosine, and tangent, okay? So our x value is negative, our y value is positive, so it's somewhere over here. So I'm going to draw my triangle. Our x, negative 1/2. Our height, square root of 3 over 2. Since it's a terminal point since they give us this, we know it's on the unit circle. That's the situations that we talk about this in. So you have square root of 3 over 2, negative square root of 2, or negative 1 over 2, and then 1. So we could easily find sine, which would be opposite over hypotenuse. So square root of 3 over 2 divided by 1, which is square root of 3 over 2. Which again, remember, your x value is your cosine, your y value is your sine, so you could just know that right off the bat. That sine is going to be your y value, and cosine would be your x value, which would work, right? Negative 1 over 2 all over 1 would be negative 1 over 2. And then tangent, well, you got opposite, so square root of 3 over 2 all over negative 1 over 2. Now, 5th grade math, maybe 4th grade, dividing by a fraction, same as multiplying by reciprocal. So this is the same thing as square root of 3 over 2 times negative 2 over 1. Well, you got 2 on top, 2 on bottom. So that equals negative square root of 3. Okay. And so that is all for today. This is your homework assignment. Again, it might be changed on the HyperDoc. If it is, follow what's on the HyperDoc. Hopefully I'll see you guys at 1 for homework questions. Otherwise, have a good day.